Is it hot or is it cold? Physical and chemical processes involve energy, so we'll see how energy is involved in these types of processes. You're out in the wilderness and need some hot water for your coffee. Here are a few questions to ask. Heat is a type of energy. Stop the video, shake hands with another person, and then answer this question: is heat transferred? And the answer is yes, if your hand and the other person's hands are at different temperatures. The answer is no if your hand and the other person's are at the same temperature. Our definition of heat is the energy transferred between two objects due to a difference in temperature. Let's take a look at what's happening at the microscopic level. Temperature is the average kinetic energy of a substance. It tells us how fast or slow the atoms in a substance are moving. So, in a hot object, atoms move fast. In a cold object, those atoms are moving slow. So a hot object comes in contact with a cold object. Stop the video and answer this question. And the answer is there's a transfer of energy between the fast atom and slow atom. The fast atom moves slower and the slow atom moves faster. That means the hot object cools down and the cold object warms up. At some point, thermal equilibrium is reached. All the atoms are moving at the same average speed. Our definition of heat is the energy transferred between two objects due to a difference in temperature. Let's identify the factors that determine the amount of heat transferred. Compare heating 1 cup of water from 25-9 degrees to 2 cups of water from 25-9 degrees. Stop the video and answer this question. The answer is no. More energy is required to heat up 2 cups of water from 25 to 90 degrees compared to 1 cup of water. So the quantity of substance being heated is one factor. What if you have the same amount of two different liquids and want to heat each liquid from 25 to 75 degrees? Stop the video and answer this question. And the answer is no. Although the amounts are the same and the temperature change is the same, different substances require different amounts of heat. You pour hot water into cold water. Will the final temperature of the water be the same if different amounts of hot water and cold water are used? Stop the video and answer that question. And the answer is the final temperature of the water is going to be different. Heat is the transfer of energy when two objects at different temperatures come in contact with each other. When we compare heating 1 cup of water to 2 cups of water, the amount of substance makes a difference. We'll look at mass. When we compare water to ethanol, those two liquids have different specific heats. Specific heat is the amount of energy required to raise 1 gram of a substance 1 degree. Specific heat also determines the amount of heat transferred. And finally, the temperature of the hot object and cold object determines the amount of heat transferred. Combine those factors and we get our heat equation. Let's go back to specific heat for a second. Read the definition of specific heat, stop the video and answer this question. And the answer is conductors such as metals have low specific heats. It doesn't take much energy to raise 1 gram of a conductor 1 degree. Heat is transferred when a hot object touches a cold object. It turns out that the heat gained by the cold object equals the heat lost by the hot object. This minus sign tells us heat is lost, that's an exothermic process. Positive heat refers to heat gained, that's an endothermic process. A hand touches the flame. Stop the video and answer these questions. And the answers are, let's use those heat equations to quantify the amount of heat transferred. Stop the video and answer this question. And the answer is 65,210 joules. We want to use this heat equation. M refers to the mass of water, so we have to convert from volume to grams. This is the specific heat of water, which we can look up. This temperature is T final, that temperature is T initial. Stop the video and answer these two questions. And the answer is twice as much heat is needed to heat 2 cups of water compared to 1 cup of water. For the second question, the specific heat of ethanol is 2.46 joules per gram per degree. So Q equals, so assuming mass and delta T are the same, less heat is required to heat the substance with the lower specific heat. You add hot water to cold water. Stop the video and calculate the final temperature of the water. And the answer is 62.5 degrees. To get this temperature, first identify what's gaining heat and what's losing heat. Then use this equation and apply it to the cold water and to the hot water. The final temperature for the cold water equals the final temperature of the hot water. Next, identify the variables we know. Finally, plug in all those variables into the equation and solve for TF. Specific heat is a property of a substance, so measuring specific heat allows us to identify that substance. So stop the video, calculate the specific heat, and identify the substance. And the answer is, the specific heat is 0.43 joules per gram per degree. This value is very close to the specific heat of iron. To calculate specific heat, first identify what's gaining heat and what's losing heat. Then identify the variables you know. Finally, plug those values into this equation and solve for SH. To take your hot shower in the morning, the hot water comes from your hot water heater. So stop the video and answer this question. And the answer is, when natural gas burns, it produces this much energy. Stop the video and answer this question. And the answer is, we know how much heat is gained by water, and the heat lost by the CH4 combustion is, this minus sign tells us the reaction is losing or producing heat, and then solve for X. Here is the price the utility company charges customers for gas and electricity. So stop the video and practice these conversions to figure out how much it costs to heat up water in your hot water heater. And the answers are, so natural gas is cheaper than electricity. Note the energy units the utility uses, therms for natural gas and kilowatt hours for electricity. Okay, so you might need some coffee after a few minutes of this video. So to keep your coffee hot, answer these two questions. And the answers are, make sure you're eating and drinking enough to do well in this class and in life. So stop the video and answer these questions. And the answers are, because the closer the initial temperature of the cold object is to the initial temperature of the hot object, the closer TF is to the hot object. In your travels, you've noticed that it's hotter in the desert where there's no water, but cooler near a body of water such as the ocean or lake. Stop the video and answer this question. Here's the answer. It has to do with specific heat. It takes a lot more energy to raise the temperature of 1 gram of water 1 degree compared to sand. So this tells us that there's quite a bit of heat transfer from the hot air to the water, which lowers the temperature of the air.